Small party. Yeah, it's very small. It's only slightly smaller than what we regularly have at regular time. All right. So we got the four people here. All right. This is day 3 of 5.09 vectors defined by magnitude and direction. We did talk about this yesterday about how vectors, they have direction and they have magnitude. Hold on a second. Sorry. Good girl. All right. By the way, there's 19 slides, including that first one. We're being recorded. Okay, magnitude and direction. So the magnitude of a vector is simply the distance from the initial point to the terminal point, as we talked about yesterday. All right, and with polar coordinates and complex numbers, you use the Pythagorean formula to find it. So that's kind of, at least that's nice. It's consistent, right? It's the same formula every single time to find distance or magnitude, whether it's complex or what's the other one? Complex or polar. All right. And don't forget the notation, vector with a line above it with an arrow. This is the vector V, and you have the angled brackets for your two.
By the way, when I was going through the lesson,
what kind of vector is this? Starts with the C. What is that called? What kind of vector? I can't hear you. Are you talking?
I just tried to say something and
you know what? You know what would help if I plugged in my headphones? That would really help. Let me try that. All right, say something. Got it. I can hear now.
Saying that in the lesson it calls them chevron brackets.
Chevron brackets. Oh. They are called chevron brackets. Thank you for going through the module. I apparently didn't read every single word.
I was trying to talk and you're just completely ignoring me, and I was hurt.
Sorry. So these are called chevron brackets. Thank you. Not angled brackets. Chevron brackets. All right. All right. All right. So double vertical bars on each side of the vector. This is the notation for magnitude. So this right here, we are saying the magnitude of vector V is equal to, well, this is a formula. It's a Pythagorean theorem. Back to my previous question, if nobody answered it. What is this form of a vector called? Starts with the C. Component form. Yep, component form. And what is special about component form of a vector? What must be true? Starts at the origin. Yep, that's what component form is. It starts at the origin and goes to wherever the coordinate is and stops there. Okay, so for direction, I feel like this is similar to stuff we've done in the past. We're still going to use the tangent, right? So the tangent of the angle is equal to y over x. So you can think of the angle being the arctan of the y value divided by the x value. So that's no different than what we've been doing in the past for other concepts. So these are the two formulas you need to know. All right. So the magnitude and direction form of a two-dimensional vector is chevron brackets, magnitude, comma, angle. So this is the form. Whereas if it was the chevron brackets with x comma y, well, that's just component form. When you have the chevron brackets, and then your first value is the magnitude, comma, the second value is the angle in degrees. So this is like the first time we get to work with degrees, it seems like. Every time it's always seems to be radians. But for this, which is good because degrees are definitely easier to, I guess, comprehend when you're trying to think of like the quadrant or how many rotations. So an example, this right here, component form is chevron brackets, -3, 2. This is component form. So we have the vector starting at 0, 0, and then it points to the coordinate -3, 2. Now, using the formula, we can convert this from component form into magnitude and direction form by using the formulas from the previous page, which let me just kind of glance back at these two formulas. So, and that's how we were able to find this.
Oh, it's like literally the same as converting from rectangular to polar.
Basically, yes, but now but these, remember, these are not complex numbers. Remember, a plus bi is a complex number, so this isn't complex numbers, but kind of really the same idea. You find the r value, the magnitude, the same exact way, the Pythagorean theorem, and you find the angle. When you did complex numbers to polar form from rectangular, it was in radians, but when we talk about real numbers on the Cartesian coordinate, you convert to degrees instead of radians. So very, very similar, which is good because it makes it kind of easy, right?
Yeah.
So
pretty much like the same as we've done, so we got the practice.
Yeah, and the problems are going to say like round to the nearest 10th or 100th. I round to the nearest 10th here. And I'm assuming I did it right. But if not, well, we got examples to see if I did those wrong. All right, so giving these component form of vectors, we want to convert these into magnitude and direction form. Or is it direction and magnitude form? Does it really matter, the wording? Magnitude and direction form, okay. Magnitude and direction form. And we want to round the degrees to the nearest hundredths, which is how many places? 2 places, yep, 2 places. So go ahead and write these 4 problems down real quick. And then on the next few pages, I think I only show like 1 at a time, maybe? Don't remember. I hope all of you like my dark theme. It's easy on the eyes. Oops. I'm just opening up my lesson in PowerPoint so I can just kind of look ahead. Okay. All right, let's do this number 1 together. All right, so just like yesterday, this is magnitude. So you think of it being the r value, it's the distance, right, from the origin. So it's the Pythagorean theorem.
Number 1 on this page is different from number 1 on the last page.
I'm glad you brought that up. I totally did that on purpose.
I totally believe you.
Have no idea how that even happened. 14, -48. Yeah, I don't know. That's really weird. -2, -4. What is that even from? I don't even know where that one even came from.
You forgot the 7 and the 6 or something.
I probably did. It's something I would do. My computer ran out of ink, so I had to stop it. I don't know. All right, we'll do this one. Let me see if that's what I did on my paper here, or my PowerPoint. Hang on. Okay, yeah, even though I wrote it wrong or I typed it wrong, I did it the way that you can see on the screen now. Whoops. Shh. All right, so everyone find the magnitude. And my pocket, my phone. We'll say, how about 1 minute, 10 seconds to try to find magnitude and the angle. This feels like deja vu from yesterday, doesn't it? It really does. All right, so in chat, what is the magnitude? 2 rad 5. Got 2 rad 5, 2 rad 5. Sarah, Chloe, fell asleep? Maybe? Got the same thing. Okay. All right. All right. I was hardly enough time. I'm sorry. Don't give up, Sarah. Don't give up. A minute and 10 seconds is really not a lot of time to work this out. But yeah, it is 2 rad 5. 2 rad 5. Don't forget the parentheses around the negatives. It does matter when you type it in. 2 rad 5. All right. So for the setup, remember we're going to do the arctan of the y value divided by the x value. Or so when you type that in, what do you get? And you can go ahead and remember, we're rounding this to the nearest hundredths. 63.43. So yeah, remember, we're talking about degrees this time. So you may have to set your calculator to degree mode, because most of the time it's in radians. So 63.43. I got the same thing. All right, so one thing that, just like yesterday, you're looking at this coordinate, -2, -4. Which quadrant is that point in? It's in quadrant 3. The degree that we found, which quadrant is that in? Quadrant 1. So what do we got to do? We just add 180 to it. Yeah, we just have to rotate it 180 to be in the quadrant 3. So don't forget that check. So we're going to have to add 180 to it. So that way the angle is in the same quadrant as the original problem. So that's how you get that. So like these problems, they're simple, but if you forget that like little piece to check to make sure we are in the right quadrant, the angle and the original point, that's how you're going to miss these.
Quick question. So we don't have to do anything with 2 rad 5 then?
Nope. That's the magnitude.
Just to the angle. Okay, cool. Thank you.
Yep.
Oh, that's right, because it's absolute value, isn't it?
What do you mean? No.
Like I mean, it has to be positive. It can't be negative anyway.
but it's not absolute value. It's always going to be positive because whenever you square any number, I'm talking about any number except 0, of course, any number other than 0, it will always be positive. Whether it's -2 squared or 2 squared, you're always going to get a positive number. So
Yeah.
if you do this part for magnitude and you get like the square root of a negative number, you messed up. You likely forgot to put parentheses around your negative values. And when you type it in, it thinks that you just want to square the number, but leave the negative on the outside. So it's different. It's a big difference. But yeah, so these vertical bars doesn't mean absolute value. The double vertical bars means magnitude when talking about vectors.
Okay,
but yeah, it's
gotcha,
always.
Thank you.
I know my answers are always like super long for like sometimes no reason, but there you go. And then, you're welcome. And then all you do is put it all together. Remember, the magnitude and direction form is chevron brackets, the magnitude, comma, theta, and theta must be in degrees, and that's what you got to do. So super easy, right? Super easy, and it's in degrees, so it's easier to like understand what quadrant you're in. I like this. All right, all right. All right, everyone try number 2. I am going to give. How much time do you want to finish this problem, start to finish, for number 2? 2 minutes? Okay, 2 minutes. We'll do 2 minutes. I like it. And then I might skip the next 2. Ooh, no, I think actually the next 2 problems are really good. We got to do them. Yeah, the next 2 are good problems. They're different, kinda. So as you're working, I'll tell you a funny story. I had to stop and get gas for my truck, and stop at Costco, and I'm filling up, and then I hear the guy's truck next to mine. He's filling it up, and it's still turned on. And I look at him. He's an older guy. He's probably like in his 70s, late 60s, maybe. And he has a big truck. And I listen. I'm like, it's running. And right next to me, like I'm blind, right? And on the one of the pillars, there's a giant sign that says "Stop Engine" in red letters, and it's all caps. And I look at that. I look at him. I said, "Thank you, car. I think your truck's running." And he's like, "Yeah." And I'm like, and I point to the sign. It says, I was like, "You're supposed to turn off your engine. It's going to explode." And he just shrugged. And I'm like, "Oh well, I guess." And I just kept filling up my truck. Yeah, I was actually concerned. His response seemed like he just didn't care, and I didn't want to get shanked or shot at, so I just stopped there. People are crazy. People are crazy. All right. You never know. You never know. Yeah. So hopefully all of you know when you fill up your tank on your car, truck, whatever, you got to turn the engine off. There's rules for a reason, and there's potential that it could, well, the fumes could combust. Even though I think it's pretty low because it has to go through your fuel filter, and then it has to be injected, and then it ignites actually in the actual like block. But it's probably happened before, and that's why they have that rule. But so I wasn't afraid. I know his mood. He's just like, yeah, and I'm like, all right, you're having a bad day. All right, what did everyone get for magnitude? Actually, what is the final? Okay, hold on. Getting ahead of myself. I'll do a survey. If you are done, give me a green check. If you are not done with this problem, give me an X. Hopefully my story wasn't distracting. Okay, everyone's done. All right. All right, so give me the final answer in chat. Type it out. Rad 577, 2.39 degrees. Sarah says the same thing. Rad 577. Okay, we got the same thing. I'm just going to tab out to my answers and see. Oh yeah, I agree with you. Same thing. Nice job. Rad 577. So there's the work. Nicely done. Nicely done. All right, let's go on to these two. All right, we'll say 2 minutes again for number 3. I think number 3 and 4 are worth doing. When you finish number 3, go on to number 4. 2 minutes. And as you're doing that, I'll tell you another fun story. So my mom, she wants to garden, and she has a garden, but she wanted a raised garden, so she had to like bend over to plant seeds or bend over to water or whatever. So I found her this it's probably like a 7-foot long raised garden I found on Amazon. It got good reviews, made out of cedar, and she got it delivered. I put it together for her. And then my brother stained it, so he sealed it with some waterproof stuff. And then I was like, well, how much dirt we need? So I use math for like very few times. Like, when will I ever use this in real life? So geometry. I measured length, width, height, and then I was like, and then I converted using stoichiometry to figure out how many cubic feet of what do they call it? Raised garden planter mix I need. And I figured it out, and I said, we need this many bags. And then when I went to Home Depot, I bought the bags, and I think it was like 3. And then I see the 3 bags. I'm like, did I do my math right? It doesn't look right at all. Like, I need to buy at least 1 or 2 more bags. But I was like, no, I did the math. It's got to be right. And went home, and we poured the dirt in there with liner first, of course, and it was perfect amount, exactly. So the math was true. Real world situation right there in play. So I felt pretty awesome that I could do that basic geometry to figure out how many cubic feet I needed. But the story gets better. My mom planted some panhead squash. I think it's called panhead squash. I'm gonna go with that. So, she told me depth, and I laid them all out, and I planted. So half of it I planted, right? And then we planted some other stuff, and I spaced it out, and I planted it. And then my brother is like, I got these seeds to plant. And he, on the other half, he planted his. I wish I could like drop a picture in New Row to show you. So my half that I planted, every seed that I planted grew. His half, there's not a single like sprout in sight. It's pretty sad. I think he has black thumbs. All right, everyone got. So what's the answer to number 3? Looks like 25, 253.74 degrees. Remember, we're nearest hundredth, so 2 places for this one. All right, 7.4. Okay, so we got 2 of the same answers. Ooh, so Sarah, your degree is in quadrant 1. Yeah, that's like messing up the quadrant and like not checking. That is probably the the most common mistake of these problems. The math should be pretty simple. It's mostly just setting it up and then typing it in to get your values for magnitude and your angle. So yeah, everyone got the magnitude correct. The original angle that you found is in quadrant 1, but the point is in quadrant 3. So you have to add 180 to it, and that was your tiny mistake that cost the entire problem. Other than that, nice job, everyone. So you don't understand. Okay, hold on. I don't understand that. Can you explain like what you don't understand so I can, I guess, be more specific with my answer?
Okay, can you hear me?
Yep.
Okay, so I understand how we know that the original problem is in quadrant 3 because of the negatives, but how do we know from after we find the arctan, how do we know like the 73.74 was in quadrant how is that in quadrant 1? Yeah.
Are you at a zoo? No,
No.
I'm kidding. It sounds like one. It's loud. So you look at your unit circle. And you look, so remember, it goes from 0 degrees to 90 degrees to 180 to 270 to 360. So from 0 to 90, your 73-ish degrees is somewhere like right over here, right? Somewhere over here. So this is in quadrant 1. And then your quadrant 2, then 3, then 4. Does that make sense, Sarah? You just gotta look at your unit circle.
Yeah, that's good. Thank you.
Yeah, no problem. Okay. All right, we all on the same page. So yeah, you look at this and you say, oh, that's in quadrant 1, but the original is in quadrant 3. So we just need to rotate 180. So whenever you have to like rotate to get to the right quadrant, you're either going to rotate 0 degrees, right? Because we are in the right quadrant. You're going to rotate 180, and in rare cases, well, not rare cases, but in some situations, you'll rotate 360 degrees. All right, number 4. Let's do 2 minutes for that. When you finish number 4, just give me a green check, and then once all of you do the green check, we'll proceed. Are you two still working? I want to make sure you haven't fallen asleep yet. All right, Jacob, you good too? Okay, everyone's good. All right. So go ahead and chat, write the final answer. Kind of curious. So everyone got the magnitude right as 50. Nice job. There's a disagreement on the angle though. So you always need to check your quadrant. Always got to check the quadrant. All right, so there's the setup. And there's what everyone should have got that, right? To start, negative 73.74. Okay. That happens. Switching around. So I kind of, in a way, gave you all a hint when I said sometimes you have to add 360 to it. Well, this was the sometime. The original problem, 14 negative 48, is in quadrant 4, right? So that tells us right away your angle needs to be somewhere between 270 and 360, correct? 270 and 360? So yeah, so you can these problems are nice because if you know the quadrant, you can say, oh, my angle better be between these two values. So for like number 3, this is in quadrant 3, so you tell yourself, okay, my angle better be between 180 and 270. And well, it is, right? For this one, we're in quadrant 4, so we should be between 270 and 360. Those are the cutoffs before you enter a different quadrant. And don't forget the negative here. So if you typed it in wrong, you probably didn't get a negative 73. You probably got something else, right? Maybe a positive. So typing in right, get 73.74 negative. And because it's negative, rather than rotating counterclockwise, which is the positive direction on a unit circle, because it's negative, we rotate clockwise. So if we rotate clockwise 73.74, which quadrant is this in? So if you rotate clockwise 73.74 degrees, which quadrant are we in? All right, I'm going to draw us a picture. We all like pictures. We got a new row we can't, like drop stuff in, right? All right, let's do that. And then I will split my unit circle in 4s. So hopefully I do a good job. It's good enough, right? Good enough. All right. So we always start at 0 degrees. Okay, that's not my pen tool. All right, we always start at 0 degrees. Why is it not working? Because my touchscreen's not working again today. Hang on. Doesn't anything ever work the first time? I don't know. I probably have to restart, and I just don't want to restart my computer because I don't know. Oh well, touchscreen's not working. I will use my mouse, even though it's so barbaric. Here we go. 0. That is a sweet looking 0. All right, so because it's negative 73.74 degrees, we are rotating, starting at 0, and you're rotating clockwise. So you are rotating a total of 73.74 degrees that direction. So that puts us somewhere, I don't know, somewhere over here, right? And this is quadrant 4. Here's quadrant 1, here's quadrant 2, and here's quadrant 3. Yikes. All right, so the angle that we found is negative 73.74. We stop here, so it's in quadrant number 4. Why is my pointer underneath? Gosh, new row. Why do you do this to me? All right, quadrant 4. And that's where we want it to be. The problem, though, is the answers that you have to put for your quizzes, your tests, even your practice problems, you want the angle between 0 and 360. And because it's negative, we have to make that correction. So to make this still be in quadrant 4, to get the coterminal angle, we have to do what to this negative degree? We just add 360. If we do a full rotation, we are back to where we started with a different number, the coterminal angle. It looks different, but it has the same value if you were to type it in. So we add 360. Now, if you did put 50 comma negative 73.74, it would be counted wrong when it was being graded by the quiz or the test, because they want, even though they don't say it, and they really should, the interval is between 0 and 360, or 0 and 2 pi if we're talking about radians. And that kind of goes back to your quiz from 5.07. I didn't emphasize it, but you want to ensure, one of the problems on your quiz wants you to put the rectangular form and the polar form. Make sure when it's in polar form, the angle that you put is between 0 and 2 pi. For a couple of the variations, whatever problem you got, it was more than 2 pi, and you had to make the correction by subtracting 2 pi however many times until you were within that interval. Even though the problem didn't say it wants it between 0 and 2 pi, it's assumed for those problems, I guess. So keep that in mind when doing your quiz from 5.07. I think it was 507. Yeah, 507. Yep. All right, anyway, any questions on number 4 before we go on? Nope. Sarah, you good? Emily, good? Everyone's good? Oh, this is not too bad. We're almost half done. All right. Second half of the lesson, we want to convert from, we want to convert back to component form from the magnitude and direction form. So we just use this, and I think we learned this as being like x equals r cosine theta. Same idea. Instead of being the r, it is, well, the magnitude of your vector v. Same exact idea, though. So the conversion between magnitude direction form is this right here. Magnitude of your vector times cosine theta, comma, magnitude of your vector times sine theta. You just type that in and hit enter. Yeah, all of these are just pretty much plug and chug. So let's look at number 5. Oops. I meant to cover up that first line. Well, there's the setup. There's the setup. This is the magnitude and direction form of the vector, converting it back to the regular rectangular form. X comma y is magnitude times cosine theta, comma, magnitude sine theta. So you would just type that in 10 cosine 60, make sure you're in degree mode, and hit enter. And for this problem, because of the angle is so nice, 60 degrees, you can actually use your unit circle if you wanted to, or you can just type it in, right? Cosine of 60 is 1/2, sine of 60 is rad 3/2. And then you just do the math. 5 comma 5 rad 3. All right, I think even 315's on your unit circle too. Let's see. It is. So for number 6, you could also use your unit circle if you wanted to. But you don't have to. You can just type it in. All right, when you finish number 6, just give me a green check. Dun, dun, dun. And the nice thing about these problems when going back to rectangular form, you don't have to make any type of like rotational correction. You just type it in, hit enter, and whatever you get is the answer. Kind of nice. Jacob, you still working? Are you in degree mode, Sarah? Multiplying 7 times sine 315. You would only get domain error if you were in. Actually, I don't know why you would get domain error. Type it in again, maybe? Okay. Okay, everyone responded. Would everyone get for their answer? Write it in chat, please. 7 rad 2 all over 2, comma, negative 7 rad 2 all over 2. Jacob got 7 rad 2, comma, negative 7 rad 2. So it looks like everyone got. No, Sarah, you're not the only one. I think Jacob didn't get it right either. I think he mistyped it. No, I think you're pretty close, Sarah. I think he just forgot a negative somewhere. So there's my work. And then, so yeah, your y value should be negative. You need glasses like me, or better lighting. I don't know. There you go. There you go. She needs better ones, better glasses. I don't either, Chloe. I don't either. All right. Let's skip these. We can come back to them. I think these are really just like plug and chug, right? You just gotta make sure you type it in right. You gotta make sure you read your screen right, and then you gotta make sure you write it right. Right? Right. Yeah. So I'm gonna skip these for now. I'll come back and show the answer at the very end. Let's get to this stuff. So in your module, they talk about ways to describe the vector. And there's 3 ways to do it. And the way that they try to explain it in the module, I thought was super confusing. I don't know if any of you tried going through it yet and understanding this part of that lesson. So I'm going to break it down for you in as few words as possible, hence my 3 bullet points. Yeah, it's a little weird. So the first one, so this is a vector in quadrant 1, right? It's 55 degrees. Wait, 55. Okay, hang on. So I label different parts here. So this is my vector. This angle between this x-axis, this angle is 35 degrees, which means if this is 35, this angle has to be 55, right? Because they are, is it complementary angles they're called? When they add up to 90, is that what that is? And supplementary when they add up to 180, I think. Okay, that's from geometry. So these angles complement each other, 90 degrees, 35, this has to be 55. All right, so I want to make sure that's clear of my labeling of my angles. All right. All right, the first way. to describe this vector. Because this vector is going up and to the right, it's going north and it's going east, we say that we are 35 degrees north, is that direction first, of east. So this first piece right here, 35 degrees north, this represents this angle here. So it is going north that many degrees. And then because it's going to the right, it's going east. So that's 35 degrees north of east. I'm going to have a bunch of examples to see to make this all click. One example is not going to do it for sure. It's going to take probably 3 or 4 to see all the different examples of the vector being in different quadrants to understand. The next way to represent the direction is north 55 degrees east. The way this works is north and east, right? This vector is between north and east. North is first, so from north, you rotate from this vertical axis, you rotate 55 degrees in the east direction. So this is north 55 east. So on your quiz, and you won't have any of these on your test, by the way, I looked. When you do this, make sure you label both angles in that quadrant like I did here. Because depending on what form it wants it in, you have to know both angles, right? All right, and the last way, which I thought was one of the coolest ways because I've seen it in movies before. I didn't actually know this. When you hear in movies, they say, oh, it's a bearing of 55 degrees. And I'm like, what does that mean? I never knew until like I made this lesson. And I was like, oh, I learned something. That's so cool. A bearing of 55 degrees. All right, so the way this works is the bearing is determined starting at due north and rotating clockwise. Super kind of weird, I guess. I don't know, but remember, this isn't about unit circles. This is talking about like a compass. So not really the same thing. So again, bearing, so 0 degrees is actually here instead of here. So starting at due north, which is at the top, and increasing degrees rotates clockwise. So we are rotating 55 degrees. So a bearing of 55 degrees is this vector. These are all very different. And if you have like, maybe on your paper or whatever you want to write these, you have like 4 different examples of all the different quadrants. And that way you can review them. It'll make more sense. Let's look at another one. I see you. I see you. All right. Ways to describe the vector. So now we're in quadrant 3. And I went ahead and I labeled my angles because you were probably only given one angle. So you either be given this reference angle of 40 degrees or this angle of 50 degrees. But if you know one, you know the other one. All right. So I want all of you to, on your paper, wherever you're writing, to try to write all 3 ways. Thank you. Thank you. Thank you. It's too much. Talking to my dog. She wants me to rub her neck for her. All right. In chat, go ahead and see if you can write one of the ways. All right. So Jacob wrote all 3 ways. So it looks like Emily says 40 south of west, but Jacob says 40 south of east. Bearing of 230 degrees. 8.5. Yep, I would agree with that. Mm-hmm. Yep, rotating clockwise. Yes. Remember, you start at due north and you rotate clockwise. Right, so I'll show that one first. I kind of think that the last way I showed, what I just uncovered, is probably one of the easiest ways. It's, I think, the most straightforward. You start at north and you rotate clockwise. So this is 180, and then 180 plus another 50 is 230. So bearing of 230 degrees. So now in movies, when they're on, like, I think I've heard it in movies when they're on ships or on subs, they talk about bearing of this, right? That's, I think, where I've heard it. All right. This next one here. All right. So the first part I uncovered, 40 degrees south of what? South of what? Emily says west. Jacob changes his mind to west. Okay. Chloe says west. Peer pressure, Sarah. What are you saying? You say west because it looks like it. Fair enough. I think it looks like it too. I would also say it's 40 degrees south of west. So 40 degrees, south is down, and this is the west side. Whereas on the previous one, it was 35 degrees north of the east side. So that kind of makes sense, right? 35 degrees north of the east side, and this one is 40 degrees south of the west side. Okay. That one seems kind of straightforward, right? All right, and then this last one. What did everyone say it was? Yep, I think that looks right. So you can kind of probably think of this one is, I guess, another way to write this first one, because now they're just putting the degree between the two angles, 50 degrees south of west. But I think I can't remember how they write it out on the modules. They might just say south 50 degrees west, but that's basically what it is, right? 50 degrees south of west.
Wouldn't it be 50 degrees west of south? Because it's already 40 degrees south of west, so it would make sense if it's 50 degrees south of west too.
Hang on. Let me go back to the other one. No. So I guess this middle one isn't rewriting this one. It's totally different the way they do it. Your angle is between south and west. And so you're starting south. So from the south side, you are rotating 50 degrees to the west.
Yeah,
way.
okay, yeah, I see that. I was just confused because I'm like it's not, it wouldn't be restating the first one because that's a 40
Yeah.
degree one.
You know, and to be honest, after we stop this lesson, I'm going to forget this. So it's good to have the examples in front of you. The only one that I remember for sure is the bearing. That's the most straightforward. The other ones, I had to look at an example. I was like, wait, how is that done again? And it's because these are so different. Going back to this one here, this first one. So you're starting on the north side here, and you're rotating 55 degrees to the east. This one here, you're starting on the south side, and you are rotating west 50 degrees. And then somebody asked about bearing. How do you find bearing? Let me switch to my my pen. My pen work again? Nope. Touchscreen's not working still. All right. So we start due north, and you are rotating all the way around to the vector. So remember, rotating halfway is 180 degrees. And then plus this last piece, you're adding 50. I wish Antonio was here. He writes so well with the mouse. What's wrong? I know. Mouse, who does that? Bubble sheets, who uses bubble sheets anymore? Is it 50 because of the, yeah, that's exactly why. Yep. Yeah, this angle's, I labeled it already as 50 degrees. Yep, that's 50. All right, let's try another one. Everyone try this. All right, give you a minute to try to write all three ways. Let's do this. Let's do the easy one first. Everyone do the bearing. What's the bearing? Bearing of 290 degrees. Where are you? Okay, cool. Oh, you're both over there. Yeah, she did vanish. Roasted. Yeah, she went to the chair. All right, bearing at 290. I agree. All right, let's do this first one. So like the degree and then something of something. Everyone give me that one. So Jacob says 20 degrees north of west. And I would agree with Jacob. Yes. So this first way, this is 20 degrees. It's north of the west side, right? 20 degrees north of the west side. So for this first way, you're always going to either have north or south first. So it's either going to be, so this, think of this as being like a reference angle direction. So you want to use the reference angle, whether it's 20 degrees in this one, 40 degrees in this previous example, that's a reference angle. And then 35 is also a reference angle. So you're either going to be north or south of either south or sorry, you're going to be either north or south of east or west. And we are 20 degrees north of west. All right, and what's that last way to write it? West 70 north, north 70 west. So for this second way, you are always going to have south or north first. I want to say that's true. Yeah, that is always true. So I guess for both of them, you're going to have north or south first. So from the north, you are rotating 70 degrees west. So you had to find that complementary angle, which is, well, 90 minus 20 is 70, right? Yeah, honestly, I don't even know why they even threw this into the module. It seems so random for this section, but I'm going over it because it was super confusing. Yeah. Yep. All right. So for both of these forms again, you're either going to have north or south first. So we have north or south, north here. This previous example, look, south and south is first. And this one, we have north and north first. All right, last example of this, and then we can go on to word problems. 1 minute, ready to go. All right, so Sarah's saying it's 60 degrees south of east. Do all of you agree with that? 60 degrees south of east? Everyone agree with that one? Yeah, it looks like everyone agrees. I agree too. All right, we got it. We all got it right. All right, what's the next one? South 30 east. South 30. We've got two people said south 30 east. South 30 east. Yep, everyone says south 30.
I have a quick question. So
Yep.
the degrees of that one, I mean the directions, is it always going to be the same, like south first and then east for each of the like methods?
Sorry, trying to focus on my writing because obviously 60 plus 40 is not 90.
Definitely not.
Yeah, math is hard sometimes, guys.
Very.
So that never happened. Yeah. But yes, to answer your question, yes.
Okay.
For both of these forms, you're either going to have south or north first, no matter which form you have. Yep.
Okay, cool. Thank you.
You're welcome. All right, and then the easy one. What's the bearing? Bearing 150 degrees. Hopefully I can add. Yep, bearing 150. It looks like I only had one typo so far this lesson. And when I have a typo like this, it means I just don't know how to add numbers in my head very well. But it's all right. Next year I'll be super smart. Right, so I gave you 4 examples to help clarify what the module I think failed to do when going over these 3 forms. Oh wait, do I have one more? Hold on. 1, 2, 3, 4. Oh, I got 5 examples. Oh, it's the same thing. Okay. Yeah, we're going to skip that. That's the exact same thing. I don't know. Duplicate page. Okay. Moving on. All right, we got word problems. All right. So it says, actually, Emily, Emily, read this to us. Your words are better than mine.
Okay. Representing compass direction applications. An airplane leaves an airport traveling at a speed of 225 miles per hour at an angle of 25 degrees east of north. Describe the location of the airplane 2 hours after taking off, round to the, I'm guessing it's supposed to say nearest whole number.
Oops, I wrote this wrong. This should say north of east. So that's a correction. Sorry. Well, there's another mistake.
Also, how did you get 675 miles?
Oh my gosh. I have no idea. Oh, wait, I do know. Okay. So I feel like I took this problem from the module. I don't know if I did. I may have made it up. Anyway, I'm pretty sure that should be north of east, not east of north. And if it is east of north, it means that 25 degrees should actually be here and not here based on this notation. but I'll double check and I'll let you know tomorrow. But anyway, let's go on with the problem like it's written right. All right, so describe the location if the airplane, describe the location of the airplane 2 hours after taking off. And this is assuming constant speed the entire duration from start to finish. So 2 hours. And the reason why it's 675 is because we're moving at 225 miles per hour. So because it's 2 hours, we multiply. Yeah, that still doesn't make 625. I don't know. I don't know what's
It
going
would-
on anymore.
50.
I don't know what's going on. Yeah, it's 450. Apparently, I can't draw diagrams to match the problem that I'm doing. So that
No.
looks like that should be 450, not 675. Oh, sad. What a sad attempt at this problem. All right.
I think you were trying to make a problem at the same time of looking at probably the one in the module, because the one in the module.
Probably. I don't know. Let's pretend this example never happened. I need to fix this and maybe show again on Bellwork or something. But again, you're not going to have any of these problems on your test, so I don't really know why I'm spending a lot of time on them. But they're in your module, so they want you to learn it for whatever reason. So, yeah, we just do the math, right? So once you actually have it in the form of magnitude and direction, all you have to do is convert it into the rectangular XY form that we learned earlier this lesson by doing the magnitude times cosine of the angle, comma, magnitude times the sine of the angle. And that's how we get 408, comma, 190. And the problem does say round to the nearest whole number, so that's why I don't have any decimals for this answer. Yikes, I have to fix this problem. I feel like it's so wrong. All right, someone else want to read this one to us? Sarah, go for it.
Okay. Representing compass direction application. A ship leaves port at noon and travels for 4 hours at a bearing of 112 degrees. The ship's average rate of speed over this time is 7 knots. 1 knot is 1 nautical mile per hour and is approximately 1.15 miles per hour. Describe the location of the ship at 4 p.m. by writing a vector in component form using nautical miles, round to nearest hundred.
All right. So this problem is a lot easier than it sounds like it. It sounds like a complete nightmare. All right. So always draw pictures, and hopefully your picture matches the word problem. Let's see if I did it right this time. All right, so it says a bearing of 112 degrees. So from here to here is 112. And if I did my math right, we don't want this angle here in quadrant 1 because we want the reference angle only. So we're going to take 112, we're going to subtract out 90, and hopefully it equals 22. Does it? Okay. So far, the diagram matches the work. All right, next. The problem says that, the average rate of speed is 7 knots. And then it also goes on to say, it wants us to describe the location of the ship at 4 p.m. And what time did we start? Oh, actually, it says 4 hours. So
Noon. It
we
says at
started
noon.
at noon.
It travels for 4 hours.
Yep, so 4 hours. So all you're going to do is multiply, 4 hours times 1, it looks like, right? Does the problem want this in nautical miles or in actual? Yeah, so it wants nautical miles. So this piece right here about it being 1.15 miles per hour, it's actually, it looks like it's irrelevant because we want 1 nautical mile in the answer. So that's bonus info. That's a distractor. All right, so magnitude is just going to be 4 times 7. Which is 28. And that's why on the diagram, we have, oh good, I labeled it right. The magnitude of this vector is 28. All right, then to find the angle, 360 minus 22 gives us 338. So when actually creating your vector, you got to be careful because we're so used to, using this word problem here. The distance is actually from here all the way around to here. That is your theta. And that's why we have 360 minus that reference angle of 22 degrees. So that gives us the true angle.
Chloe is asking how to do these problems because she keeps getting kicked out.
Kicked out?
Because of her
Her internet.
Bad.
Oh, bad internet. Yikes. I would say, Chloe, you're gonna have to probably watch this part of the recording again, or the part you missed. It's a lot of stuff I just said. It's okay. It's not your fault. Your internet happens. I'm guessing you have Cox internet. Yeah. Yep. Yeah, they're bad. Everyone thinks they're good. They're terrible. They're unreliable. I have CenturyLink, and everyone says they're bad, but it may not be as fast as Cox. But let me tell you, it is more reliable, in my experience. But anyway. All right. Next, we need to write this in the magnitude and direction form. So magnitude being 28, direction being 338. And then to convert it back to the rectangular form, or sorry, component form of a vector, where it's the magnitude times cosine of the angle, comma, magnitude times the sine of the angle. You just type that in, hit enter, and it wants us to round to the nearest hundredths, like it says in this last line here, round to the nearest hundredths. So here is magnitude and direction form, and here is component vector form. So really, this problem seems harder than it really is. All I can tell you to do is draw a diagram and label stuff. And then when you actually pull out the angle, and don't be fooled by this reference angle, because we're so caught up on doing that the last 4 or 5 slides, that the angle when going into magnitude direction form has to be the angle as if we're using a unit circle. This is 0, rotating counterclockwise is positive direction, and we need this angle, which is 338 degrees. So a lot to remember here. And that's my last example. I'm going to check up on this problem because I think I wrote this wrong. I think that should be north of east. But I'm going to double check. I'm I'm pretty sure that's just the typo here that makes the problem so wrong. But anyway, other than that, again, don't freak out about these. You won't have these problems on your test, and on your quiz, you might have one. I didn't check, but it's not bad. Draw a picture. All right, guys, thanks for coming. And as always, I hope you learned lots of stuff.